to throw it over to Logan and Ed as they're going to tell us a little bit about lifter bushings. Stick around.
Hey everyone, I'm Ed Kiebler from Rottler Manufacturing, and man, what a great discussion that was with the legend Pat Musey on nitrous. We're here in front of the F69A from Rottler Manufacturing, and Logan Miles is going to talk to us a little bit about installation of lifter bores. We're going to see a short video after this, but just wanted to give you a little bit of a live presentation on lifter boring. So, Logan, tell us a little bit about yourself.
I've always been in the machining side of things. I started back in high school about 4 years ago. I've always had interest in it. Then I went to a technical college for about 16 months, and then after that, I've been working here ever since.
How long have you been working here now?
2 years now.
2 years. Yep. And what have you learned so far?
I've learned a lot.
Yep.
A lot to learn. Yep. I was on the just machining parts and stuff. Then I switched over to the automotive side, and there's a lot to learn there.
Yep. How has the machine been for you? You know, this young generation, you guys take to computers like we used to take to rotary phones, okay? But how's the machine been for you to learn? Is it a simple process, or?
Yeah, it's been pretty easy to go over from what I used to do to this. It's been pretty easy to learn, and everything on this machine I can't complain about.
Okay, all right. So tell us a little bit about what you're going to do here, Logan.
On the lifter bushings, we have installed, these are CHE lifter bushings for Morel Lifters on this LS block that we're giving away.
Why do we need to? This is a brand new dart block, so obviously the lifter bores are in a pretty good location. We believe they're in a good location to start with. Dart's a precision manufacturer of engine blocks. Why are we going to put lifter bush? Tell the audience why we would put lifter bushings in a block like this.
Well, first we probed off the dowel pin, got our locations of our lifter bores, and we're putting lifter bushings in it to correct it if it is off a couple thou. That way our lifter bushings are directly where they need to be.
And aren't the Morel lifters a keyed lifter?
Yeah. These are keyed lifter bushings for keyed lifters.
So we have to put those bushings in order to keep the lifters from rotating in the bore. Is that correct?
Yeah.
Yep.
That way they can stay lined up with the cam.
Okay. All right. And in this process, what do you go through to actually install these things? You talked a little bit about the probing and determining locations, but what's the actual process that you're going to go through, Logan? I assume these lifter bores started at a smaller diameter, and obviously with the bronze bushings you had to do something to remove a bunch of material in order to put those bushings in?
Yes, we use I believe it's an 8 flute 1-inch end mill that we plunge. For these bushings we plunge it to get it out, rough it out to 1 inch, and then we have a single point cutter that would take it out to inch 049 because they have 2 thou press. And then we have a tool that we put in the machine to press the bushings in.
And when you're pressing those bushings in, do you just press them in any direction or any old way, or is it important to orient those in a particular way?
Now, they've got to be oriented the way the key's got to be oriented straight towards the cam lobe, or the lobe on the cam. That way when you put your lifters in, the keyway is right and your lifters will ride on the lobe that's on the cam.
So I'm sure that's a very critical process, and Mr. Callies, who's kind of sitting in the background here, could probably talk to us a little bit about how important that particular process is. John?
Hey guys, this is a keyed lifter that goes in. This is one of our Black Mamba units that doesn't use any needle bearings. And the bushing we did, we went together with CHE on the development so the oil system works as we want it to make the lifter have durability. So you can see the keyway here, and we have to have this to where when it's lined up, the roller is absolutely in line with the lobe on the cam. And if you're off 2 or 3 degrees, you're not going to get any durability. So this machine allows you to lock that in where you want with it. We made a tool that goes up and you can set where you want it and then press it in and it will come up. You insert on the next part, press it in, come up, insert on the next, and then eventually you come in for the final bore. Now, because this shrinks when you press it in, then we want somewhere around an inch, a thou 4/10 to a thou 6/10 clearance between the OD and the ID. And this machine, I was so impressed because we were able to hold 1/10 on the diameter.
John, you and I have been around a while. We're kind of, as I call us, we're the gray hairs of the industry. And we got this great young machinist here who's starting out, and he's probably never experienced the way that we used to have to put lifter bushings in. That was a very involved process.
It was using hand tools and guides, and it took you about 8 hours to do it. And then it was not near precise time. And right now, mounting the block, going through the boring process, installation, final bore, you're down to somewhere between an hour and a half and 2 hours for the complete job. So we've taken it from 8 hours to under 2 hours, and that's big time. And accurate, you know.
Yeah. So what we've done really is we've taken a process or an operation that used to take 8 hours, and brought it down to an hour and a half to 2 hours.
Correct.
Now in my world, that's a huge productivity gain, which should go right to the bottom line for you shop owners that are looking at something like this. The ability to install lifter bushings just went from an 8-hour process to an hour and a half, 2 hour process. That's an excellent increase in productivity and profitability.
And you see, let's take it one step further. Let's say you're a Pontiac buyer where you can't get a new Pontiac block for 30 years. Now you have the ability to take an old block, take the lifter bore bushing, sleeve it, and come down to where you have the correct clearances to make the engine operate for a long time.
So we've kind of talked about that. Logan, tell us a little bit about feeds and speeds. Give our audience a little bit of technical information here, you being the machinist. I know when you're boring out that you talked about a single point cutter. What kind of feeds and speeds do you typically run to try to hold those kind of accuracies, not only on the cast iron, but also on the lifter bushing itself?
With a single point cutter, I usually do 300 RPM, 3 thou per revolution. Now on the bushing, I usually feed it up just a little bit, so it leaves a good finish for the lifter. But on the 1-inch end mill that we use, rough-wise, I usually use a slow RPM and a fast feed rate to keep the chatter down.
Okay. All right. Well, what we're going to do now, Logan, is we're going to toss it over to our video and let everybody see in detail how we actually install these lifter bushings. And the other thing we want to remind you is factoring. I hope you all enjoyed the last segment. I believe it was with Dart Machinery. So we're here at CNC Blockworks today, and we're going to be talking to Logan and Embry. Embry is the owner of CNC Blockworks, and so they're going to be showing you how this machine actually functions today. I just want to talk just for a small minute here about the capabilities of the machine. So what we're going to demonstrate today is the ability of this machine to bore lifter bushings. In today's world, a lot of people use the keyed style lifters. So we're going to take this block out to an oversized, press in keyed lifter bushings and then rebore them. And typically what you'll do is you'll use the center line of the main bore to do our locating from. And the machine will actually offset for the lifter bore positioning. And that works very well, especially in a new block like this. This is a dart block, and they do a very good job of manufacturing. So we can use the main bores on this particular block and do a great job. However, with this machine and our fixturing, you can, if you want to get to the nth degree, you can actually relocate this block from the cam bores and be dead or directly on the center line of the lifter bore. So it gives you even a little bit more precise way of doing things. So I'm going to introduce Embry here. He's the owner of CNC Blockworks, and he's going to talk just a little bit about what they're going to do today.
Thank you, Ed. Today we're going to go through the process of installing bronze lifter keyway bushings in an LS block, a dart block. And Logan is going to take the process forward for you. He's going to show you the tool selection, the process that we go through from start to end. We're going to install the bronze bushers. They are 1 inch 0.59 in diameter. Our process is we bore out with a end mill to 1 inch 0.40. Then we use a 1-point cutter and we take it to 1 inch 0.59 with a 2/1000 press on it. And the final step is we set the diameter to according to the lifter itself to the finishing cut, and we finish ours with a 1-point cutter. Today the keyway lifter, which we use, are Morels. They have a single slot, and in this slot a key, pretty much, which is part of the lifter, rides in it. It's like a tie bar between the other roller lifters. It eliminates that tie bar, it eliminates that weight, allows for a lighter lifter, higher RPMs, more efficiency in the engine itself. As you can see, we have the galley around to allow the oil to circulate around the outside instead of through the middle of the lifter, but it also has access hose to it to allow it to lubricate the lifter without over lubricating it and causing a problem of oil drainage back into the bottom end of the engine. It's a proven product. I've used it myself. Yeah, I think in the end you'll see this is a better product for your high performance camshaft and lifter desires. At this time, I'm going to hand it over to Logan so that he can show you the tools, and you can see the capabilities of this machine. It's far superior than anything else that I've seen in the market.
Hey guys, I'm Logan at CNC Blockworks today, and today we're going to be showing y'all the tooling for installing these keyway lifter bushings from Morel. First step that we go to is we have this inch 040 end mill that we got from Rottler, that Rottler sent, and we plunge it out from 843, which is standard size, to inch 040, and this leaves us 19 thousandths for a finish cut to leave a better finish, that way when we press our bushing in. But you just plunge this through and takes it out to inch 040. And then we have our single point cutter that we have adjusted to inch 059. It leaves a really good finish, and it just leaves a good finish for the bushing to be pressed in afterwards. And then what's left is our bushing installer that presses the bushing in. It locates off of these two little dowel pins, that way when you press the bushing on this keyway, you want it facing towards your camshaft, and it clocks it at the 12 o'clock or 6 o'clock position, whatever you need it to. But it does a really good job. But we'll get to work and we'll see how it goes.
Hi, this is John Callies. I'm the engineering manager of Morel Lifters. And we start out, I want to show you our plant is in this square here. It is established in 1991. It's 100,000 square feet. We have heat treating in-house. There isn't anything that we have to send to the outside. We're real pleased this year. Chase Elliott won the NASCAR championship. We've been with Hendricks for over 14 years. This is Rick's 13th Cup championship, and this is a big deal. We have a little over 300,000 race miles now on our lifters through NASCAR races. Our lifter categories, on the top here we start with our street hydraulics, and the street hydraulics we build for small block Chevy, big block, Ford, LS, and Chrysler, as well as Oldsmobile, Pontiac, 409 Chevys. Now this liver uses a 700 wheel in it, and when you move up, the next is our performance hydraulics, our 4602s. This goes to a 750 wheel down here, 750 diameter, and also the body material is different than our street hydraulic. You're moving up in quality and durability. Then we have our high RPM hydraulics, and you'll notice that it has this EDM hole on the front that determines that's the type of lifter it is. And what this allows you to do is you get higher RPM plus a higher spring pressure load carrying capacity. Then we go to the HLT hydraulics, and this is a special limited travel for certain types of racing. Our street mechanical hydraulics, again back to a 700 diameter wheel, and it really is this lifter, and we build a special hourglass piece that goes where the hydraulic piston goes to become solids. Then we move again to our performance mechanicals. This has been around for quite a while, the 4604s. It's a good durable lifter. And we came out a year ago with our Sportsman Racing, we call it a Sportsman Pro lifter, and it's cut up on the sides so you can go to a low base circle and still have it operate properly. Our Pro Series mechanicals, we make those in an 842, 875, 903, and 936 diameter. Then we move to our newest part, which is called the Black Mamba Light. Now this axle has no needles in it. The wheel rides on the axle. This is our Black Mamba with the DLC coating. The DLC coating reduces friction and is wear durability. This is our top line lifter right here. From here we move to our keyed lifter. This is a Black Mamba, again no needles, with a keyed, and this is done very well. And then you have your cup lifter, which has a needle bearing in it. Now, the reason we can't run this is strictly because of the rules in NASCAR. You have to have a bearing. The Black Mamba lifter, the benefits, one, you have an 842 diameter with a carrying capacity load of a 1-inch lifter. This axle has an 470 thousandths diameter axle, and the matrix material is a B624L. Again, no needle bearings, full pressurized oiling to the lifter and wheel. Wheel runs on an oil wedge. Has a diamond-like coating. It's rebuildable. We make it at our plant. Currently available for small block, big block, LS. Also available 903 for small block, big block, and low power A and B lifters. This shows the oil flow. So the oil comes down the lifter from the oil galley, and comes in a V inside the axle, and an oil wedge starts to film, so you have a full film around the axle. This is another view where we took the oil, comes down, comes into the axle, down in the V, back up, and starts the oil wedge. Now, what we did here on the keyed lifter, this has a bushing, and we work with CHE on the design. It means when you put it in the block, it's already finished. You don't have to worry about how it oils. Now, this particular one is small block and big block Chevy, and this is the CHE part number, their phone number to obtain the part. Similar situation, except it's a different bushing and a little different oiling. You can see the slots off to the side, and this is for the LS and the Ford as well. And of course, we've gone through the oiling. It all works kind of the similar way. And the one thing is that the film wedge you sit on is similar to your rod bearings and your engine and main bearings. Now, this is the load carrying capacity between a needle bearing and our axle that runs with no needle bearings. One thing I would point it out, if you look, the axle size is a 360 versus our 500 diameter on our Black Mamba. Now, the one thing is on a needle bearing, at the highest load, you only have 3 needles carrying the load. This is called a Hertzian stress point. So you have a small point at the top of the needle and the bottom of the needle, and you have 6 of them that are carrying the whole load capacity. Whereas now on the Black Mamba, we have a full film wedge on the whole bottom section. So the area is, 10-fold bigger. So it means that the load carrying capacity goes way up because the area you're running on the oil. Now, one thing there's a misconception on in measuring lifter to bore clearance. And what I want to point out is you must have a vernier caliper on your micrometer. And you must have a bore gauge that reads in tenths. And this is all the points on all our different style of lifters of where you measure to get the diameter of the lifter. Now, I'm just going to run through, because it's kind of simple. These on the barrel, where you have 1, 2, 3, 4, 5, these are 100 thousandths at each point. So you have 100 thousandths, 200, 300. The lines in between are 25 thousandths each. And then on the barrel, these are 1 thousandth. And then when you match up the veneer, you're matching up these lines with what best fits the lines on the barrel. Well, the 2 lines up. So if you take it down here, it's 800 thousandths plus 250 thousandths, 17 thousandths, and 2 tenths for a total of 8422. Now you've properly measured the lifter. We have a specific installation process, and there is a break-in. We put a special lube between the wheel and the bearing when it's sent to you. We do not want you to wash the lifter, because you'll take that out. And then we want you to run a break-in period of 25 to 30 minutes, varying the RPM from 18 to 2200. After break-in, relash the lifters. The lash should not vary more than 1,000. Do not use any oil restrictors. We want all the oil going to feed the bearing. And on the lifters, we have one circuit that feeds the axle and another circuit that feeds the push rod. We recommend 15 to 17 tenths on the aluminum blocks and 14 to 16 tenths on cast iron block. We want the bore to be 2 tenths in roundness. Now, all this, and you'll see in the demonstration of installing the bushings, boring the bushings, we want a slick finish on the bushing bore, because the nicer the finish, the better the oil travels around the lifter. Now, I've made up this chart. It's called a lifter bore clearance worksheet. You can download it off our website. And what you do is you first put in all the lifter diameters here. Once you put those in, they automatically transfer over to the bigger sheet, and as you can see, you've got the customer's name, what he's doing, what type of oil he's running, so you have a good thing to go in the reference of the engine build. Now, once you put that in, you know we're going to shoot for, on this one we can be 14 to 16. So when you have, the program is not live here, this is a picture. But I could change this that I wanted 0.0015, and it automatically changes all the figures to read right. So you know this is what I want as the final bore. And on the engine we're doing here today, it'll be a 0.9373 is what we're shooting for, and 15.0015 clearance. Anyway, this is a handy sheet, easy to fill out, then you writing the 3,000 figures down. On our website, first thing is to look at Morel products. You can go down and any one of these part numbers, you click on the part number and it shows you the lifter that you're after or you're looking at. Then you have this arrow, so you get 4 pictures of each lifter, so you can peruse what lifters, what the applications are. Then we have tech information, and I'd like to point out that on the technical information, if you click the mechanical lifters down here or hydraulic lifters, it gives you the types of hydraulics, what the spring pressures are you should run, what lift rates you should run. So it helps you decide what lifter fits your particular application. We do the same thing for all the mechanical lifters. It's a handy reference guide, and it's on our website. You have left-hand and offset lifters, and this is same deal in the tech area. It tells you how to detect what's a right-hand offset and a left-hand offset, so you can order the right part number when you need it. We have a section on how we want hydraulic lifters to be adjusted, and it's a good technical section to read through to help you. If you're interested in any of our products, please look on our website. We make from street to the very top performance. I'm sure there's something that would help you. We'd love to talk to you. Thank you.
Hi, I'm Lake Speed Jr. and welcome back live to the Engine Performance Expo studio. I'm joined with John Callies and Ed Kiebler, and we've got some questions we're going to dive right into based on this last section about lifters and lifter bore bushings. So kind of fun topic for me anyway. I love the DLC coated lifters. They look cool and they work really well too. So let's jump right in. First question is from Steve. When going to a larger lifter, is a bushing really necessary in an aluminum block? John, what's your thought about that?
No, you can run it directly against the aluminum, but if you're going to use a keyed fixture, you're screwed. But we do have lifters, bigger lifters, that don't require a key.
Got it. So a keyway lifter, you have to have the bushing, obviously, to direct it. Without that, though, you can run directly in the material. Makes sense. Okay. Another question from Dwayne. How are you taking the cut on the block facing, taking care of that block facing?
On the block facing, I assume he's means the top of the lifter bore.
I'm assuming,
What I believe he's talking about, right?
No, I think the top of the block.
The top of the block.
Right.
Okay. Well, the
Serpentine.
so the top of the block is done with a CBN insert if you're in cast iron, or it's done with a different style of CBN insert if it's a bimetal block. I hope that answers his question.
Yeah, there we go. So next question here was from Bill. When going to a 903 lifter for street use on a big block Chevy iron block, just bore the block and not use bushings? Is the factory block acceptable material for that?
Well, usually when you go to a 903 lifter, you have a way bigger camshaft. And so you have to be careful about the oiling system working with the lifter. And that's where a bushing will take care of all of that. Now, can you do it? Yes, you can. You just have to be careful of when you look at the parts and make sure it's going to be a correct system.
Well, that brings up my own question, actually, based on that. You're talking about a bigger cam, bigger valve springs. Is there kind of a rule of thumb for when you should move to a bushed lifter because of that bushing having better lubricity, better support for that higher load that's generated by either a bigger cam or aggressive profile, bigger valve springs?
Well, one thing that it allows you to do is many of the older blocks don't have the lifter bore bushing or the lifter bore in the correct area.
Ooh.
With a bushing, you can extend that and make a lifter to work in an older bushing on a bigger size.
Oh, perfect, great. So Steve, that's a question. When you're doing the bushing, do you finish hone to size?
That's really neat. The machine itself, we bore through to the finished size. We might take out 3 or 4 tenths with a different feed or speed. We do not feel that you need the crosshatch marks to get the oil to work properly. We
Okay.
find the finer the finish, the better the control of oil. So we recommend don't spend the time doing anything other than just boring it.
Okay, great. So another question here from Charles. Did they use Loctite when pressing in the bushings? Ed?
No, you don't. There's a 2/1000ths press on the bushings, and so we do not use Loctite typically when you're pressing in the bushings. We will use a lubricant, a lubricant to press them in, but no Loctite.
Okay. Same guy asked the same question back to the aluminum block. Could you not cut a key into the aluminum block body to make it a lifter bore?
You can do anything. It's just, and we've all done it, but, the proper and easier way is to make a bushing and install it.
Got it.
And I might add to that, if you were to just put that broach in there, you still don't know if your lifter bushings are in the right locations. That's one of the things, especially with factory blocks and all. You'll find that if you were to blueprint the lifter bore dimensions or positions, they would be out of tolerance typically. So that's another reason we put bushings in.
Oh, great point. So probably enough time for probably one more question. This is from Pat. Do you recommend straightening the lifters for spread port heads instead of using 180-degree offset intake lifters?
If you do a keyway in an offset, then everything's perfect. When we do a tie bar, we have inspection of the tie bar angle to make sure we're within tolerance to work right, so you don't get a washing machine action during the cycle.
Yeah. Great point. So, okay, John, you need to head over to see Joe because we got a special thing coming up here in a minute.
What a day, what a day, what a day. My brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.